Okay. Bohr's atomic model. This model is important right now for NEET and for JEE, right? Because first time we explained about the exact about electrons, right now. First time we explained. But some points are important and some points become demerits of atomic models, right? So first, this model was based on the quantum theory of radiation and classical law of physics. This is important, right? Now, classical law of physics means an moving object, right? Now, calculation velocity of moving object, and then classical law of physics. Bohr's model is applicable only for single electron species. This is also important. Bohr's atomic model is applicable only for single electron species like hydrogen, like helium plus, lithium plus 2, beryllium plus 3, right now. And Bohr's model is based on the particle nature of electrons. And Coulombic force, Coulombic force Kq1, Q2, R square, centimeter force MBR, angular momentum MBR. This formula I will explain later, like why electrons moving around the nucleus are stable because of these two forces, right now. Coulombic force, attraction force, and centrifugal force due to rotation on electrons in outwards one towards one, right? And that is called centrifugal force. Centrifugal force, and this one is the centripetal force, right? And that's why electrons are stable and revolve around the nucleus in a fixed path, right? Important postulate. Okay. First postulate given by Bohr's. First postulate: atom is nucleus where all proton and neutrons are present, and it is situated at the center of atoms. Right now, it is also explained by Rutherford. This first postulate is copied of Rutherford. Right now, Rutherford explained. Right? Rutherford said all means mass of atoms are concentrated in the nucleus of atoms, right now. And in a nucleus contain proton plus neutron, right now, proton plus neutron. Second postulate: negatively charged electrons revolve around the nucleus in the same way as the planets revolve around the sun. This planetary motion of electrons are explained by Rutherford, right now. Rutherford copy. The path of electron is circular. The path of electron is circular. Means electrons revolve in a circular path around the nucleus. Right? The attraction force, Coulombic force, or electrostatic force between the nucleus and electrons is equal to the centrifugal force. Kq1, Q2 upon R square is equal to MBR square, MB upon R square. Right? Centripetal force and centrifugal force both are equal. Centripetal force, electrostatic force, Coulombic force, and centrifugal force, MB upon R square. Right now, attraction force toward the nucleus, centrifugal force away from the nucleus. Right. Third postulate. Bohr said electrons are revolve only in those orbits which having angular momentum is equal to nh upon 2 pi. Means angular momentum is integral multiple of h upon 2 pi. Right now, that is MBR equal to nh upon 2 pi. This n equal to number of orbit, means this orbit is the integral multiple of h upon 2 pi. Right now. And later this postulates become demerits of Rutherford Bohr's classifications right now, because he not explain why electrons revolve with this angular momentums, right? H upon 2 pi. He not explain. And H upon 2 pi generated by hash we can write as hash equal to H upon 2 pi, where n equal to positive integer number equal to Planck's constant. What is the value of Planck's constant? Constant 6.6 into 10 to the power minus 34. Unit is important right now. What unit? Joule second. Right. Joule second. Right. It is the Cannon value such as first H upon 2 pi means electrons are revolving in a first cell. Right now 2H upon 2 pi means electrons revolve in a second cell. Right? 3H upon 2 pi means electrons revolve in a third cell. Right? Fourth postulate, the orbit in which electrons can revolve are known as a stationary. The orbit in which electrons can revolve, that is called a stationary orbit, because this orbit energy of electrons is always constant. You know, right now energy is always constant in each orbit, fixed orbit. Right? Fifth postulate, each stationary orbit is associated with some energy, right now, with a definite amount of energy. Therefore, these orbits are also known as energy level. Are numbered as the first cell K, L, M, N, O, P, Q, R, S, first, second, third. Right now, each cell associated with a fixed amount of energy. Right now, fixed amount of energy, and we can calculate that energy by formula E equal to minus 13.6 now. Minus 13.6 Z square upon N square or N square upon Z square? Z square upon N square. Unit electron volt, right? Unit electron volt means another formula. Sixth postulate first. The emission and absorption of energy from photons can only occur when electrons jump from one stationary state to another. Like when electrons absorb energy, that time it excites from lower state to higher state, right now. And when electrons emit energy, that time higher state to its stationary orbit or fixed orbit come, right now. Energy is absorbed when electrons jump from inner orbit to outer orbit, and it is energy emitted when electrons move from higher to lower. Right now means N2 greater than N1, whether emission or absorption of energy will produce. Right now, understood this point? Fifth postulate. Radius of various orbits. First time Bohr explained. Bohr give the formula for calculations of radius of orbit. Right now, of each orbit. And the formula first with the derivations. Remember these formulas, right now? R equal to 1 time in the derivatives. And need also they already asked, right? R equal to N square upon H square upon 4 pi square M KZD square. Right now, after putting the all constant value, H square, 4 pi square, M mass of electrons, right now, and K Coulombic constant, right? And Z atomic number, E electrons, charge on electrons, right now, and N number of orbit. After putting all the constant, we get R of radius of orbit, N equal to what? Number of cell. N represent number of cell. R equal to 0.529 into N square upon Z in a unit angstrom. Right now, unit should be. Remember this formula for all the derivations. Maximum 95% question you can solve by this formula, right? 95 to 98%. R equal to 0.529 into N square upon Z unit angstrom. Right now, angstrom. R is directly proportional to n square upon z square. N increase, radius increase. Z increase, radius decrease. Right now, Z means what? Z, atomic number. And you know, left to right in our periodic table, atomic number increase. Right now, that's why radius decrease. Already you know, right now, periodic table, right? And top to bottom, n increase, atomic radius increase by this relation, right? In our JEE Mains na, in advance, they can ask for relations like this na. Means so you have to give the answer by making relations. R equal to n square upon z square. R directly proportional to n square upon z square. Why in a periodic table, left to right, radius decrease and top to bottom radius increase. Okay, now you can give the answer. Second factor. This is the second factor, right? Where n equal to number of orbits, z atomic number, right? Velocity. First, remember this formula. Velocity equal to 2 pi kz square upon nh, right now, upon nh. And after putting all constant value, we get 2.18 into 10 to the power 6 z upon n, meter per second, right now, meter per second, unit. And formula should be remembered, okay? All formula, right now, one piece, okay? This is Morse formula. And last two, wave, right now, wave formulas, right? Quantum formula. Right now, one piece, okay? And repeat 5 to 6 times, right? And after that, practice questions, okay? Easily you will remember all formulas, okay? And velocity directly proportional to z and inversely proportional to n. Z increase, velocity increase. N increase, velocity decrease. Okay. Time period. Time taken to complete revolutions. Right now, what is the time period of Earth? Time period of Earth. 365 days, na? Okay. Rotation of Earth on its axis is 24 hours, right now? And time period of Earth 365 or 366 days, right now? Right? 365 days. Means Earth complete its rotation around the sun in 365 days, right? That is called time period of Earth respective to sun, right now. Time taken to complete revolutions in a nth orbit, which time taken by electrons complete revolution. That time period, distance upon velocity, you know, 2 pi upon velocity of that set. And after putting the all last formula, after putting all the values, you get T directly proportional to, here is not constant, consider, okay? Directly proportional to NQ upon z square, right? NQ upon z square. And frequency 1 upon T, means z square upon NQ, right now? Time frequency 1 upon time per second. This type of numericals you can solve, right? Energy of an electron. Fifth application of words, right now. Energy of an electron. First, E equal to half mv square kinetic energy plus Coulombic potential energy, right? Kinetic energy, local energy, kinetic energy plus potential energy, right? Half mv square plus kV. After putting all the constants, we get the E equal to, remember this formula, okay now? Okay? Remember this formula. E equal to 2 pi r square mk square z square E 4, right now E or 4 upon L square H square. After putting the all constant, we get the energy equal to 21.69 into 10 power minus 19 upon L square Z square upon L square. Unit joule per atom. Okay na, joule per atom. If examiner will ask the question in a joule per atom, means you have to use this formula, right? 21.69 into 10 power minus 19 Z square upon L square joule per atom. And most of the question they ask in electron mole. Okay, most of the electron mole. So electron mole in electron mole minus 13.6 into Z square upon N square. Z square upon N square electron mole per atom. So okay, I remember this formula. Both formula 1, 2, 3 formula. Try to remember. And remaining, if you know the one formula, you can convert. Right now, joule to electron volt. Easily you can convert. Right? Unit conversion, energy unit conversion in a mole concept I explained. Right? Kilocalorie, kilojoule you can convert, and in a kilocalorie also you can convert. Right? A unit conversion. Right? This formula you have to use for 90% process, right? Minus 13.6 into Z square upon L square. This formula is applicable only for hydrogen-like species, right? Bohr's atomic model based only applicable for single electron species, right? And based on classical law of physics, and based applicable only for single electron species, right? Since n can have the integral value, it follows that total energy of electron is quantized. Quantized means what? Charged, right? Having charge, having some energy. Okay. Not the negative sign indicate the electron is under attraction, is bounded by the nucleus. This negative represent means electrons are bounded with the nucleus with the attraction force. That's why we use negative. Okay na? And one relation conclusion. Remember this right now. Total energy equal to minus of kinetic energy equal to potential energy upon 2. Remember these relations. Okay na? For solving the questions. Okay. Directly remember these relations. E equal to minus K equal to PE upon 2. Potential energy upon 2. Okay. Remember this relation. First, important definitions. Ionization energy. Ionization energy. Energy required to remove electron from ground state to infinite, right? And that is called ionization energy. Right? Means N1 to N2 equal to infinite. Right now. Separation energy means to excitation of electrons from second, third, fourth, and so on to infinite. That is called separation energy. Right now, excitation energy, excited state, excitation energy. N1 to other than infinite. Right now, N1 to 2, 2 to 3, 4, 5, 6, other than infinite. Okay, now that is called excitation energy. Excited state already used. I explained in a chemical bonding right now, and lots of examples to solve excitation state. All these kinds of energy are always positive because required energy, right? Endothermic means required energy. Endothermic na means positive, right? Energy level you can find right now for hydrogen atom. You can find difference. First, and try to remember for the first for hydrogen, at least for hydrogen atom, right now. For first, second, third, fourth, sixth, and seven up to sixth. Try to remember. First cell associated with the minus 13.6 electron volt. Second cell minus 3.4. Third cell minus 1.5, 1 electron volt, 4 minus 0.85, and 5 minus 54, and minus 6 minus 0.03435. Right electron volt. Try to remember up to 6. Okay. For fastly solving the questions. Okay, now try to do this energy first. In a one energy diagram, all energy, ionization energy, excitation energy, and saturation energy. All are mentioned, right? And you know, increasing number of cells means energy increasing, right now, because energy directly proportional to n square. Energy is directly proportional to n square. Means n increases, energy increases, right? Means each cell 1, 2, 3, 4 means continuously increasing, right now. Potential energy also increase, but kinetic energy minus sign, right now, means inversely proportional, right? So kinetic energy decreases, potential energy decreases, total energy increases, but kinetic energy decreases. Okay, so short trick by this you can use for solving the numerical side. Which of the following transition minimum energy released? Minimum energy released. What is the concept for finding the energy? If electrons come near to the nucleus, means maximum energy released, right now. If electrons are excited from, it's like ground state or near to the nucleus to other. First check N1 now. If N1 is a minimum, means energy maximum, least energy or required energy. Okay, because if electrons are present near to the nucleus, for removing that electrons required more energy. Because if electrons present near to the nucleus means bounded, means force of attraction is more, right now. That's why required energy more. If required energy more, means released energy more. With the answer. Minimum energy released means N2 to N1 means higher state to lower state. Answer please marking. Okay, first option N1 to infinite means required energy, not released, right now. Third, N4 to N5 required energy, right? Fourth, 3 to 1 release energy. And more, right? And then ask minimum, right now, minimum. And N1 equal to 1 means it move near to the nucleus, means more energy release, right now, more energy release. N3 to N2 means away from the nucleus, so minimum energy release as compared to this code. Both are correct, but minimum energy, right now, minimum energy having this one. Second option. Understood everyone? And 3 times in a NEET, this type of question they ask, right? In a JEE, also 3 to 4 times, right? Which of the following transition minimum energy is absorbed? Now check to lower to higher. Energy absorbed means lower to higher, right? First, N1 to infinite. Minimum energy. Energy absorbed, right? The first energy absorbed, but having maximum. Check, compare. Third, N3 to N2. Energy released or required? Energy released, right? Fourth, N3 to N1. Energy released. Second, N4 to N5. 4 to 5 means it is present away from the nucleus, right? So 4 to 5 as compared to this one. First, N1 means electrons removed from first cell means energy required maximum. Right now, so option second. Third question. According to the Bohr theory, which of the following transition hydrogen atom give the rise to the least energetic photon? Transition give the least energetic photon means which having the least energy required, least energy, right now. Transition means energy release. Transition energy release. Sorry. Transition energy release. And the following transition with the least means minimum energy. In a which minimum energy release. Answer. First, N5 to N3 energy release or required? Energy 5 to 3 energy release, right? Second, 6 to 1 release, 5 to 4 release, 0 to 4 energy required. We force option eliminate right now. First, second, third. Now check which is present near to the nucleus. Okay, now near to the nucleus means more energy release. N2, 3, N2, 1 means maximum energy release. Right now, as compared to these three, maximum energy. Then this one, then N equal to 4 means away from the nucleus. Away from the nucleus. Right now, means minimum energy released. Okay. A spectrum. Okay, a spectrum definitions you can read, okay now? And what is the application of a spectrum? Let's see. Emission and absorption, two types of a spectrum. Emission and absorption. Right now when electrons absorb energy, that time one electromagnetic wave is released, one electromagnetic wave produced, and when it release energy, that time also electromagnetic wave produced. Right? Note, the spectrum of sunlight is continuous emission spectrum. Example, rainbow. Okay, the spectrum of hydrogen atom in a light emission is discontinuous spectrum. Discontinuous spectrum, you know, because fine lines are present. Right, fine lines are present. Right. Emission and absorption spectrums are photo-negative of each other. Okay, photo-negative of each other. Okay. First, emission. Okay, now this is the for hydrogen spectrum. So the emission spectrum means 2 to 1, 3 to 1, 4 to 1, 5 to 1, 7 to 1 up to infinite. If electrons from infinite or nth cell will come to the first cell, then that spectrum is known as a spectrum ultraviolet region, lies on ultraviolet region, and that series, that lines is known as, let me be known as Lyman series. Right now, if electrons comes from first cell, that series is known as Lyman series. Second, then Bauman, third, fourth, and 5, 1, and Humphrey. Right now, 6. If electrons are come to the 6, then is called the Humphrey, and 8 series associated with the electromagnetic waves. Right now, first this is the first Lyman series associated with the UV region. Right now, UV region, and second Bauman series with the visible region. Means question, which series we can easily observe? Bauman series. Right now, because we can see color of a spectrum, right? And that's why we can easily differentiate between this. Okay? And after partial, bracket and fern, partial, bracket and fern are lies on a infrared region, right? And Humphrey far infrared. Humphrey far infrared regions. Okay. Lyman series discovered by Lyman. These series are all our scientists' name, right? And this Lyman, Bauman, Parson, all our scientists' name. Okay. Region UV region, visible region. Remember in which region these series are lying. Okay. Now remember according to this you can solve the questions. Okay. N2 maximum. N1 is fixed, right? Now for Lyman series N1 always fixed 1. Bauman N1 2. And partial N1 always fixed, right? Now fixed. And bracket N1 fun 5, N1 5, and Humphrey 6. N1 always fixed, N2 can be different, right? Now N1 always fixed, N2 can be different, right? Now if they will give the questions, a series in spectrums are lying on a N1 equal to second, mean which series? Bauman series, right? N1 equal to 3, which series? Parson series. Electrons are come in second, third. According to this, you can give the answer. Okay, now N1, remember N1 for Lyman, Bauman, Parson, bracket, fern, and Humphrey. Okay. Calculation of number of spectral line, total number of spectral line you can calculate, right? Now by this formula, N2 minus 1 into N2 divide 2, right? Now by this formula you can calculate total number of spectral lines, total number of lines, okay, for given data. Number of absorption line equal to number of Lyman series N2 means number of absorption spectrum emission. Now absorption, okay, now absorptions. N2 minus N1 fixed, right? Now N2 minus N1, N2 minus N1. For Bauman N2 minus N2 minus N2 2, N2 minus 2, right? Now for partial N2 minus 3, and bracket N2 minus 4, and 1 N2 minus 5, and Humphrey N2 minus 6, right? And you can give the answer, right? Absorption spectrum, okay. Rydberg formula. He gave the formula for calculation of wavelength associated with the electrons, right? Associated with the electrons. When electrons jump from higher orbit to lower orbit in a hydrogen atom, like this, then the frequency or wavelength or wave number or of radiation immediately calculated by the Rydberg formula. Okay, now each electron is associated with the wavelength, wave number, and frequencies, right? Now, okay. What is the formula? Rydberg formula. First formula. May equal to 1 upon lambda equal to RZ square into 1 by N1 square minus 1 by 2 square N2 square. First, remember this formula right now. 1 by lambda equal to RZ square into 1 upon N1 square minus N2 square. And 1 upon lambda, you know, 1 upon lambda is what? Wave number or frequency? Wave number, right now. Wave number denoted by nu bar, right now, nu bar. Wave number equal to 1 by lambda equal to RZ square, okay, 1 upon N1 square minus 1 upon N2 square, right? And after multiplying both sides C, okay, now C, it's become C upon lambda. Both sides multiplied with C, na? Multiplied with C and C. C and C. Okay. C upon lambda equal to RC square. You know. And C upon lambda equal to what? Frequency. Right now. V equal to C upon lambda. Means frequency equal to RC square 1 upon N1 square minus 1 upon N2 square. Right? R equal to the what? Rydberg constant. Value of Rydberg constant? 109,678 per centimeter, or other 1.1 meters per 7 per meter, in a meter, per meter, right now? Or remember this value, okay now? Most of the time you have to use this one. 1 upon R value, 1 upon R. 912 Angstrom. 1 upon R equal to 1 upon R, Rydberg constant. 912 Angstrom. Okay, remember this value. 912 Angstrom. Okay. Derivations, how we get long derivations. You can read now derivations. Okay. Some important rules. For S line any series, N1 decided by the name of series. Right now, Lyman series means N1. 1. Hun means N1. 5. Right now, like this, N1 decided by the name of series. Okay, and N2, N1 plus X. X means what? Number of series. Right now, number of series. For the last one, limiting line, first line or a starting line, first line or a starting line, you can give the, and the last line or limiting line of any series, N1 by name of series, and last line of limiting series, N2 always infinite. Last line or limiting series, N2 always will be infinite. N1 decided by the name of series, okay? And you know, first absorption or emission line, first line N2 to N1, that is called alpha, N3 to N1, that is called beta, gamma, theta, like this and so on. Right now, first, second, third, alpha, beta, gamma, we didn't know. Right now, numbering. Okay. And first line, starting line, initial line, lambda maximum, wavelength maximum, and frequency minimum, energy also minimum. Okay now, if wavelength maximum, and frequency minimum, energy minimum, because you know energy formula equal to h nu, right now. H nu equal to C upon lambda, means inversely proportional. Energy is directly proportional to the frequency and inversely proportional to the wavelength. Right, and that's why lambda maximum, energy minimum, and frequency also minimum. Okay. Frequency and energy both are directly proportional, right? Means energy increases, frequency also increases, right? And wavelength decreases. Okay. Last line or limiting line or marginal line. For last line, limiting line or marginal line. If electrons are zero, means energy absorbed from N1 to infinite, means lambda minimum. Okay now? Minimum, and frequency maximum, energy also maximum. Okay. Limitation of Paul-Salamink model. Limitation. Some points we couldn't explain. Right now, that become limitations. Bohr-Steele does not explain the spectrum of multi electron atoms. He couldn't explain the, like multi-electron species means what? Bohr's only explained for single electron species, right? Means which atom contain one electron. He explained only for that, right? And why angular momentum of the revolving electron is equal to ns upon 2 pi? We not explain why electrons revolve with the angular momentum nh upon 2 pi. We not explain. Right now, when scientists ask Bohr's why electrons revolve with this angular momentum, he not say anything related to this. Okay, but it was correct right now. Further, it was proved by which scientist? De Broglie. Right now. Further, it is proved by De Broglie concept. Right now, De Broglie concept. Okay. Third, Bohr's interrelated quantum theory of radiation in classical law of physics without any theoretical explanation. Bohr theory based on the classical law of physics. Classical law of physics, but we know according to the classical law of physics, we can calculate only of macro. We can calculate velocity of all data of macro object right now. Means big object like block, like car, like train. We can calculate. But Bohr's without any explanation, he said this theory is based on a classical law of physics. And you know better, classical law of physics explain only about macro molecules, right? Not micro. And electrons is a micro molecules, right? That's why it's become the matter. Okay. Bohr theory does not explain the finer structure of a spectral line. And you know, in a one spectral line, in a one alpha spectral line, one spectral line containing the finer structural lines, right now. Further, one spectral lines contain many more spectral lines, okay? And he don't explain. He don't say about that thing. Okay? Finer structure that is a spectral line obtained when spectrum viewed by the spectroscope of more resolutions. A spectroscope is the device we can is by this device, right now. Bohr theory does not explain the splitting of a spectral line. He not explain about the splitting of a spectral line in the presence of electric field and magnetic field, right now. And in the presence of electric field, that is called electric field, a Stark effect, na? A splitting of a spectral line in the presence of electric field, that is called a Stark effect. And a splitting of a spectral line in the presence of magnetic field, that is called Zeeman effect, right now? Zeeman effect. And physics sir will explain well in the class 12, okay na? Related to this topic. Why these finer structural lines are split in the presence of electric field and magnetic fields, okay? The model consists of wave mechanical model of atoms. Now wave nature of electrons. Okay, now come to the wave nature of electrons. Wave mechanical model of electrons. De Broglie concept. First time De Broglie concept. De Broglie dual nature of matter. First time De Broglie explained the dual nature of electrons. Wave nature and particle nature. Okay. And dual nature of matter means wave nature of electrons. First wave nature of electrons by De Broglie. Okay. So friends, Louis De Broglie suggested that nature of light is both of a particle and a wave. If light can show both nature, wave and particle nature, right? Means electrons can also show wave and particle nature. For this line, only for this line, we got Nobel Prize. Okay, now De Broglie. Only for this line. Means if light particles having both nature, wave and particle nature. It's also having electrons having wave and particle nature. Further it is proved, and for this line he got Nobel Prize. Okay. According to De Broglie, the wavelength lambda of an electron is inversely proportional to the momentum. Okay, now it's a momentum. Lambda equal to h upon p, and h p equal to mv. Right now p momentum formula everyone know na, mv. mv means after putting the all value lambda equal to h upon mv. Remember this formula, okay? H upon mv. And De Broglie hypothesis applicable for macroscopic as well as microscopic. means de Broglie, this hypothesis is applicable for both macro and micro, but for micromolecule it is not significant right now. Macromolecules, for macromolecule it is not significant right now, because we know after calculating for macromolecules we get the in a minus 34 or more than 30 minus 35, right? Minus 30 more than minus 35. I mean this is not possible. Okay, for calculation of this wave, for detect of this wavelength, this is not possible. Okay, and having no physical significance of the macro molecules object, macro object. Okay, de Broglie wavelength in terms of kinetic energy. In terms of kinetic energy, you know kinetic energy equal to half mv a square, right? Half mv a square. If after putting the half mv a square m into k multiplied both side, m right now means m square b square. You know mv is equal to what? Momentum. mv momentum. After putting the all things here, we get the me equal to mk right now, and lambda equal to h upon mv. You know mv right now, and mv equal to 2mk in terms of kinetic energy. mv equal to under root 2mk. Right? After putting the lambda equal to h upon 2mk, right? And when the charged particle carrying q charge, q coulomb, accelerated by the time potential difference v, in a charged particle when accelerated with the potential v, that time kinetic energy equal to q into v. That time kinetic energy equal to q into v. Okay, now joule. And we know other formula of kinetic energy, h upon under root 2 mk, and kinetic energy equal to m upon q into v. Q into V. This V is a what? Potential difference voltage, applied voltage, right now. Lambda equal to h upon 2m qv, 4 electrons. After putting the all data, 4 electrons, mass, strength constant, and this one potential. Strength constant and mass. After putting, we get the under root 150 upon V. V is what? Potential difference voltage in a angstrom. Okay, now in a angstrom. Remember this formula for easy calculations. Under root 150 upon V in a angstrom. Okay, now for charged particle in a electron volt. Charge having charge electron volts. Okay, that time. The wave nature of electrons was verified experimentally by Davisson and Germer. Verified by Davisson and Germer. The wave nature furtherly divided by Germer and Davisson. He explained the wave nature of electrons. Okay, after that he got overthrust. Okay. Bohr theory and de Broglie concepts. Okay, intermixing of Bohr theory and de Broglie concept. According to de Broglie, the nature of electrons moving around the nucleus is like a wave that flow in a circular orbit around the nucleus. Means according to de Broglie, the nature of electrons are flow around the nucleus in terms of wave, right? So wave means it's a form trough and crest, right? Like we flow circular orbit around the nucleus. Second, if the electrons are regarded as a wave, the quantum condition is given by Bohr in which theory is radially fulfilled. Okay, when we consider wave, that this theory is completely fulfilled. Okay, if the radius of circular orbit is r, then its circumference will be 2 pi r. 2 pi equal to n lambda. N equal to what? Number of orbit, number of cells, right? The number of cells, lambda associated with the associated wavelength with that cell. Okay, now means 2 pi r equal to n lambda number of waves, and we know lambda equal to h upon mv by de Broglie concept. 2 pi r equal to nh upon mv. Both concepts are experimentally proved by de Broglie. Okay now? Both concept. Electrons revolve with the angular associated with the angular momentum nh upon 2 pi h upon 2 pi. That is experimentally proved by de Broglie. Okay now? And remember this formula: 2 pi equal to n lambda, 2 pi equal to n lambda. Okay, 2 pi equal to nh upon mv. mvr equal to nh upon 2 pi. That's the angular momentum, which is the integral multiple of h upon 2 pi. Here n equal to 5 means this having a wavelength 5, right? 5. Number of waves are 5. Okay. Similarly, the between the de Broglie waves of and waves and boats are 2 pi equal to n lambda, n equal to what number of orbit number, sorry, n equal to number of waves. Number of waves you can find by number of orbit, right now. Number of orbit means second orbit means wave number 2, third orbit wave number 3, fourth orbit wave number 4. Like this you can give the answers, right? Wave nature. Heisenberg uncertainty. Now, one concept. Remember, Heisenberg uncertainty. Heisenberg said it is impossible to measure. It is impossible to measure at the same time both momentum and position of the electrons. Right now, momentum and position of the electron at the same time. It is nearly impossible. Right? He explained Heisenberg uncertainty. And if you remember, quantum model, right now based on the Heisenberg uncertainty, right now, quantum model based on the Heisenberg uncertainty, right? Because of this line, it is impossible to measure simultaneously to exact the position and momentum of microscopic particle. If you know, if I want to click the image, at the instant electrons are evolving very fast, like towards the in a atom. When we click the image, that time it's when we click image, after a few seconds, after microsecond, electrons positions get changed, right? Electrons position get changed, and it's possible after taking energy from our surrounding, it get excited, means position as well as velocity is different, right? Means when it will be excite means n change, velocity change, all things get changed, right? So that's why it is nearly impossible. We can find only one of them, right now. Either if we know the momentum, means we cannot say about position. If we know position, means we cannot say about momentum. Okay. Mathematical form, the uncertainty measurement of the position delta x and the uncertainty momentum delta p are related by delta x into delta p is more than less than equal to h upon mv, right? H upon mv, right? H upon mv, p equal to mv, delta p and delta v. This uncertainty in a momentum comes by velocity of electrons, right now, because you know number of cell change with velocity change. Velocity formula equal to 2.18 into 10⁻⁶ z upon n, means n change, velocity change, right? So these derivations you can read, right? All relations 1, 2, 3, 4 relations. For easy calculation, if you want, you can remember this value, right? H upon 2 pi, h and 2 pi, these are constant, right? H upon 2 pi, 0.527 into 10⁻⁻34 joule second. This value, if you want, you can remember for easy calculations. Okay. And you know, when delta x is 0 means delta v infinite. When delta x infinite, delta v 0. Delta v 0. Right now? Means if you know the one position, with other we know. Delta x is infinite means delta p 0. Delta x 0 means if we know the position, delta x 0. 0 means what? Means we know the position. Infinite means what? You know? Right. You know the no. The principle is contradicted in the circular path of electrons of the molecule. Why this is the contradicted? Because Bohr said electrons are revolving in a fixed path, na? Okay, listen, this line is important line for of NCERT right now. Why this is contradicted? Because Bohr said electrons revolve in a fixed path with a fixed velocity. Right, a fixed path with a fixed velocity. It's all we know. But we know, according to Heisenberg uncertainty, no fixed path, no fixed velocity. Right, no fixed position, no fixed velocity. That's why this point is contradicted with the Bohr's atomic model. Bohr said electrons revolve in a fixed path. Right, in a stationary orbit. Stationary means what? Fixed. A stationary orbit, so fixed path. Right. That's why this point is contradicted with the Bohr's atomic model. Okay. Now, up to this you can do. Okay, now next lecture only one topic is remaining: quantum mechanical model. Okay, quantum mechanical model. I'll explain now next class. Okay.